In this lesson, we'll learn about different global illumination solvers or engines, which are Pathtracing and UHDcache. We'll learn how they differ in the way they calculate GI in the previous lesson, and now we'll learn where and when to use each and take a closer look at the UHDcache options. We'll be trying to keep it as simple as possible, as user-friendly and simple UI and UX is what Corona all about. We'll be working with the same scene as the previous lesson.
Let's go to the render settings window and the general settings tab.
The primary engine in Corona is always path tracing or brute force. When you change the GI mode to single bounce only, you are only using the primary engine, and that primary engine is always path tracing or brute force. And when you are changing the GI mode to full multiple bounces, you're using both the primary engine and the secondary engine. The primary engine is always path tracing, and the secondary engine, you can define it here using this GI solver menu, which is going to be path tracing or UHDcache based on the scene, and we're going to be talking about this in the next lesson. But for the secondary solver, we have both path tracing and UHDcache. Path tracing is an unbiased, brute force, and accurate solution. It creates a GI sample for each and every point, so it's much slower. And UHDcache is biased, slightly less accurate, and much faster. UHDcache needs less GI samples, and for the points that didn't get any GI samples from the UHDcache, it just gathers information from the nearby GI samples and averages them to calculate GI info for that particular point. For the primary solver, we don't have any choice, and it should be path tracing all the time. But which one should we use for the secondary solver, path tracing or UHDcache? Well, it depends on the situation. For interior scenes, you should use UHDcache because the direct lighting won't reach a lot of the areas of the interior that you're trying to render, and you need a lot of bounced lights to make those dark areas brighter. And as UHDcache is much faster, it does the job much quicker and better compared to path tracing. So for interior shots, UHDcache is the better choice. For exterior scenes where you have very complex geometries like trees and foliage, but very simple lighting, normally a Corona sun and sky or an HDRI image in the environment, you should use path tracing, because the direct lighting easily reaches everywhere and you don't need a lot of secondary bounces of light rays. And as you are dealing with very complex geometries, UHDcache can cause some artifacts in your render. So for exterior scenarios, path tracing is the better choice. For studio setups where you have a bunch of direct lights shining on the subject, because the lighting is very simple, meaning the direct light can reach everywhere, you can use path tracing, but as normally you don't have very complex objects, UHDcache can be used as well. If you are coming from other rendering engines, don't think of UHDcache like other secondary solvers in those engines. UHDcache is much more accurate than those, less splotches and noise, and you can confidently use it as your secondary GI solver. If I set my secondary solver to path tracing as well, you can see it doesn't give us any option. When you use path tracing as your both primary and secondary solvers, you are basically opting for a completely brute force and very accurate solution, and it doesn't require any further action from you. You can immediately fire the render and be sure to get a very accurate, though slower solution, especially in interior scenes, and much noisier as well in interior scenes. If I start the render now, you can see there is no GI pre-computations, and the render starts immediately because we're using path tracing. But if you set your secondary solver to UHDcache, you get a UHDcache rollout down here with some very simple and self-explanatory options. You have two simple presets. If you are basically rendering a still frame, just use the still frame fast pre-computation option. And if you are rendering an animation with multiple frames, to avoid flickering in your GI solution, use the animation flicker free preset. So if we set the preset to still frame and run the render, you noticed before the render started, we had this pre-computation phase, those green points, which are the samples. Now, this one just took 2 seconds for this scene. And if we change the preset to animation and run the render again, you notice the pre-computation phase is much longer because it needs to be more accurate. It puts more samples. Therefore, UHDcache places way more samples in the scene, which takes longer. The precision value controls the quality of the UHDcache. The default value of 1 is pretty good. Lower values will result in faster and less accurate solution. So if I set it to something like, let's say 0.1 and render the scene, the pre-computation is very fast and obviously less accurate. And if increased to, let's say something like 2 and render the scene again, you can notice the pre-computations become more accurate but slower, and it takes longer. You should avoid using high values here, and I would say in most cases the default value of 1 should be enough. So let's set it back to 1. By the way, if you want to reset any parameter to its default value, simply right click on its spinner and it resets to the default value. Next, we have this save load section, which becomes very important in certain scenarios. If you are rendering an animation with moving objects and cameras, which are most animations, the pre-computation mode should always be set to calculate from scratch for every frame, and after render mode should be set to discard. This way you avoid any chance of flickering to the minimum. If I close these windows and get back to the scene, I have a bunch of dynamic animated cubes in the scene. And if I go through my timeline, you see how the scene is unfolding. In a scene like this, when you have moving objects, you need to make sure to calculate the UHDcache from scratch for every single frame. But if I hide these cubes, now we are in a situation where the camera moves but the object stays stationary. We don't need to pre-compute the cache for every single frame here. We can be rendering like 1,000 frames, and if the pre-computation phase takes only 10 seconds per frame, we can be wasting up to 3 hours. Now let's see what can be done here. For a single frame, if we change the after render mode to save to file, we can save the UHDcache to our hard drive and reuse it later on without having to recalculate it. So let's click on this browse button. I have this deleted folder on my desktop. You can put the file anywhere you want, and let's name the cache file something like simple room and click on this save button. Now if I start the render, as soon as the pre-computation phase is finished, the UHDcache file will be saved to disk and ready to be reused. So let's start the render and stop it as soon as the pre-computation is finished. Now, if I stop the render and go to that deleted folder where we saved our file, you can see we have a simple room.uhd file, which is the cache file we need. If we get back to Max and change the pre-computation mode to load from file, and the file name is already defined accurately here as we just saved it out. If not, make sure to define the right path to your cache here. If we start the render, you notice the pre-computation phase is skipped altogether because we already have that info saved out, and the final rendering starts immediately. Now, how to do that not for a single frame but for a couple of frames, an animation. Remember, we only do this when the animation is just a camera move. If there is any other type of animation, like object movements, the light changes throughout the motion, you should always use the calculate from scratch mode. But fortunately in this case we only have camera movement, so let's save some time. First, let's close the frame buffer and get back to the render setup window. We are dealing with a 31 frame animation. The camera movement is fairly simple. I say that we can try to calculate the UHDcache every like 6th frame and get a pretty good estimate for the UHDcache. Now, if we set the mode to calculate from scratch and after render mode to save to file and then change the file name to something like simple room camera. It can be anything.
And from the output section, change the frame range to all frames and frame steps to 6.
Now, if we start the render based on these settings, we will be rendering every 6th frame, and the UHD cache info for each frame will be added to that simple room camera.uhd file that we set in the file name. But there is actually even a faster way to do that.
The way we have it set up right now is that we calculate UHD cache for frame 0, save the info to the file, then we go to frame 6 and calculate UHD cache from scratch and add the overall data to the original UHD cache file, which was that simple room camera. But if I go through my timeline from frame 0 to frame 6,
we can see the camera is barely moving. So what if I can tell Corona that, hey,
frame 0 to 6 is not that different.
Would you please, when trying to render
frame 6,
just take the cache info from
frame 0
and add new samples on top of that, which makes the process much faster. Then we go 6 frames forward
to frame 12.
Take the info from frame 1 and frame 7 and add on top of that wherever needed, and so on and so forth for the remaining frames. To do that, you need to change the pre-computation mode to try to load plus append. We can use the same file name or create a new one down here. And the last thing to do, because we only need the pre-computation phase and don't need to render the final image, we can set a time limit like 1 second, so the final render will be stopped 1 second after the pre-computation phase is over. Now let's start the render. For frame 1, the pre-computation needs to be done thoroughly. Then the final render begins, but because we set a time limit of 1 second, it stops immediately. Then it goes to frame 7, and because we already have all of those sample points from frame 1, the pre-computation would be much faster, and it only adds new samples where it needs them. When the render is done, now we have a UHD cache file that can be used to render the entire animation. And if I go to that deleted folder, we can see the file. Now, if we change the pre-computation to load from file and make sure we have no time limit for our render, and make sure it's a single frame output, now we can render any frame or the entire animation without having to wait for the pre-computation phase. So if I go to frame 19 and start the render, you notice the render starts immediately without the need for pre-computation. If we can kind of wait a bit, you can see we don't have any issue, any GI issue, we don't have any misplaced shadows, any contact shadow issues, everything looks just fine.
We can change the frame range to all frame and start rendering the entire 31 frames without having to do any pre-computation, and if so, the rendering starts immediately after hitting the render button.
Okay, that's enough for this lesson. We learned about path tracing and UHD cache in this lesson and how they work and when and where to use each one. We continue with the topic of lights and lighting in Corona from the next lesson. See you there.